posted in the Facebook group a couple weeks back about how I was going to do some different electrical videos, some troubleshooting and things like that. And this is going to be the first video in that series. Now, to start off, we should probably start with who I am and what I do. I work for a commercial and industrial HVAC company out of Charlotte, North Carolina. I go into all different types of places. I go into, I've been everywhere from places that manufacture and mill flour to places that manufacture pharmaceutical drugs, to power plants. I think probably about the biggest place that I've been has been a couple of the power plants in this area. But needless to say, my job is about 75% to 80% electrical. The refrigeration side of my job is actually very minimal. It's a lot of control work and checking power and things like that. So that's kind of where my background is and where my qualifications are. Okay, so the first thing we need to do is we need to outline a couple of terms. And we need to understand what those terms are. And of course, guys, always be safe when you're working around electricity. It is dangerous. If you don't feel safe working around it, hire a professional. I can't stress that enough. The biggest thing is we want to, whether we're working at home, working at work, or we're out camping, we want to return the same way that we left. But the first term we need to understand is volts. Volts are, if you think about electricity and water, in the sense of water, volts are the amount of pressure being applied to the electricity to send it down the wire. So your standard outlet in your house is going to be a 120 volt outlet, and that's going to be the same in your camper, or just about any outlet you run across is going to be 120 volts. The next term that we want to understand is going to be amps. Amps are the amount of work that the electricity is doing, and the higher the amp draw, the more work that that's doing. So if we were to go and check our outlets in our house, let's say, we would have 120 volts applied to that outlet. If we were to put an amp clamp on that outlet, we wouldn't have any amp draw through that outlet because there's no work being done unless we plug in a vacuum or a television or a phone charger, something to do work. There's no amp draw coming out of an outlet. It's only the voltage to the outlet. And the third term we're going to need to understand is resistance. Now, the amount of resistance dictates how much work that the electricity has to do. The higher the resistance, the more work the electricity has to do to make it through that to complete the circuit. Electricity is always looking for a path. It wants to go back to its home. So it's actually coming into your outlet or into your house and through that outlet, and say you plugged in your vacuum cleaner. Your vacuum cleaner has a motor inside of it. That's the part that's actually doing the work and has the resistance in it, so to speak. That's very basic. I know there's probably somebody out there that's going to watch this and argue with me, but this is a very, very basic, most easy definition that I can give you guys. It's going to go through that motor and it's going to return on your neutral back out to your panel, and depending on how your house is wired, it's either going to go back to your transformer on your pole for your power lines, or it's going to go to earth ground. But that's what electricity is looking for. It's looking for that circuit. If it doesn't have that circuit, it's not doing any work. Resistance can also be found in the wiring itself. Just the wire going from the power station to the transmission lines and things like that. There's resistance through all those wires. That's part of the reason why if you ever look up at your power line, it's a pretty big, hefty wire up there. The reason for that is they want as little resistance as possible going down that line so that they can get the most power delivered to your house. The final term that we're going to want to understand, and this really only applies to the guys that are going to be out there boondocking and maybe using a generator, is we need to understand Hertz. And Hertz is a little difficult to understand. So I've got a whiteboard here, and I'm going to draw you guys a picture of what Hertz is. But basically, Hertz is the amount of cycles that the electricity is going through every second. So in the United States, we use the 60 Hertz cycle. And what that means, if we were to have, clear a little bit of this off, if we were to draw a line across this whiteboard here, that would be 0 volts. Okay? And then if we were to draw another line at the top of the whiteboard, we'll call that 120 volts positive. And we'll write that over here as well. And then we're going to draw a third line down at the bottom. And this is going to be 120 volts negative, because we use alternating current. So what's going to happen when we have a Hertz? We're going to start at 0. We're going to draw parabola. You guys may remember that term from geometry. And it's going to go up to 120 volts positive, go back down, cross 0, down to negative 120 volts AC, and then it's going to go back up to 0. Okay, and it's going to look like this. And this sinusoidal wave here is 1 Hertz. 60 Hertz means that this is doing this 60 times a second. Every second in the United States. Now,
move your hand.
Now, in other countries, France, a lot of the European countries, they use a 50 Hertz cycle, which means that this is going to do this 50 times in a second, which is actually a little bit more of an efficient design because you get less crossing of 0, which makes the power a little more, just a little bit more efficient. But that's Hertz, and that's really going to come into play, like I said, with the boondocking guys who are going to be using generators and things like that. You're going to want to make sure that if you're running on a generator, that your generator is putting out a pure 60 Hertz cycle. You know, if you're not putting out that pure 60 Hertz cycle, you have the potential to damage things in your RV. But those are the terms that we need to understand. Okay, so on from understanding the terms, once we have a good grasp and understanding on what the electricity is doing, we need a way to measure that and put that into terms that values that we can understand. And I know somebody out there is probably saying, well, why do I need to know all this? I'll just call if I have a problem with the power at my campsite, I'll just call my campsite manager and he'll come over and check it and everything. Well, one of the last places that I worked before I went to the company that I'm at now was a construction company. And one thing that I learned at that construction company is the person that has all the answers, not necessarily all the answers, but they have all the measurements. That's a better way to phrase it. The person that has all the measurements is the guy that wins the argument every time. Even if all of his measurements are wrong. You guys know your trailers. If something electrically isn't working right and you think it's the campground, if you have the means to be able to show the campground manager this is wrong, that's gonna 9 times out of 10 he's gonna go, look, he broke out some kind of tool, I don't know what he's talking about, he said something about hertz and volts and amps and I don't know, and I'm just gonna move him to another site. You know, I can't tell you guys how many times I've been in my camper and needed a meter. I can give you 2 quick examples real quick. One of the first times that we brought the camper out, we bought ours new. It's a Sonic 200 VML. And I think it was the second or third time we brought it out, the DVD player would not play the audio through the speakers in the coach. I could only get it to play through the television. So because I had my meter with me, I was able to take the DVD player out real quick, and I found that the B channel which should be the inside on my coach, had gone dead. It wouldn't send out the power to the speakers to make them work. So I switched it over to the C channel because my C channel was still working, and we got through that trip. And when I brought it back to the dealer to get them to warranty the DVD player, they originally told me, well, there's nothing wrong. It was unplugged in the back and we plugged it in and it worked. And I was able to argue with the guy and say, look, no, that's not what happened. And the reason that I know that's not what happened is because I pulled the radio out and I flipped it over, and you don't have power coming out of the B channel on that radio. I said, so that unit needs to be replaced because it was originally hooked into B. And, you know, the warranty is only a year. I'm not going to have a year and 2 months down the road, the C channel goes out and you tell me, well, you know, there's nothing we can do, you got to buy a radio. So I was able to get that one changed under warranty because, again, I had the measurements to prove to him. The other time we went, I forget which campground we were at, but anyway, we had an issue with the shore power, and I was able to go out, I diagnosed it with the meter, and called up the camp manager. He came out and took a look at it, and he said, well, I don't know, I don't really do anything about electricity. And I broke the meter out, and I said, look, here's the way it is. You have 3 legs that come into it. You have a hot, a neutral, and a ground. And your hot is supplying your power, your neutral is returning your power back to either, again, your transformer on the pole to go back to the substation, or it's going to earth ground. Now, the thing about, and then there's a ground. The ground is only for safety. That is strictly there that in case something goes wrong and there were to be a hot to come in contact with the trailer, that is strictly there to protect the user. Okay? And the situation that we had going on was the neutral was broken. And the maintenance guy came out and he said, there's nothing wrong, you have 120 volts power, it's in your camper. And I said, no, you have a broken neutral. You have an open neutral somewhere. Because the power needs to go back to neutral. I keep going back to this vacuum cleaner reference, but if you were to look at the plug on your vacuum cleaner for your house, it only has 2 prongs on it. That's because you don't need that ground. That ground is strictly a safety. He was measuring from hot to ground, and he was getting 120 volts because there's a 120 volt potential difference of energy there. Because I had a meter with me, I was able to plug it in and go, look, if I go from hot to ground, you're correct, I do have 120 volts. But that doesn't mean a hill of beans to me because I need my power to go from hot to neutral. If I go from hot to neutral because I have a break in this wire and it's not going back to the panel like it's supposed to, I don't get power. I need flow. It has to go in a circle. And I was able to convince him that there was a problem and that we needed to either repair the broken neutral or move to a different campground. But that's enough on those subjects for right now. We're going to move on to your meter selection. Now, as a personal preference, I use Flute meters. You know, I go into, like I said, I go into power plants, I go into places that have a lot of energy and a lot of potential for me to get hurt if I don't mind my P's and Q's and have something that I can trust and rely on. So the first thing I do before anything at all is when I walk up to a unit, I have my little hot stick here. And the reason that I carry this with me all the time everywhere is because this is a non-contact voltmeter. This means that all I have to do is put this up to something that has electricity in it, a wire. I can stick the little prong here into the end of an outlet, and I can it'll alert me if there's power there. The first thing I do is I turn this on before I touch anything metal, any disconnect switches, any fuse panels, anything like that, is I run this on that fuse panel. there's a problem in that panel and there's a hot wire touching that metal panel and I touch that metal panel, I just created a path to ground, and that electricity is going to go right through my body to the ground and stop my heart. So the first thing I do is I turn this on, I touch it to the panel, and as long as this doesn't go off, I know I'm okay. Now, that being said, these are not the end-all be-all. Okay, these things, I've broken these things before, I've damaged these things to where it doesn't matter what I do, it won't tell me that there's power there. Always, always, always test your equipment. Okay, I stick this on the panel, it doesn't do anything. I go to an outlet that I know is working, or I find a light somewhere that is on that I know clearly there's power going there, and I stick it to that light, it goes off. Okay, I know my tool is working. That's first and foremost. And these things are cheap. You can get these, I mean, you don't have to get the Flute one. The reason I carry the Flute one is really just because the supply houses I go into carry the Flute one, so it's convenient for me to get it. It's right there. If I break one or lose one or drop one or something, I can just get one when I'm in a parts house. But you can get these for about $20 or $30 at Home Depot or Lowe's. I think even like a lot of the Ace Hardwares carry them, places like that. So when we go camping, you walk up to that power pedestal to plug your power in, to plug your camper in. I run this thing on that thing before I touch it because, I only have one life, and I'm not putting my life in anybody else's hands. I've seen enough bad wiring to know. So the next thing is have a good quality set of meter leads. I don't know what happened, but I had one set of meter leads that did get, it broke. The insulation on them broke right here. And it was a really dangerous scenario had I not picked it up, because I use primarily this clamp meter here. So when I walk up to a unit, I clamp it onto a wire and it hangs down. And when it hangs down like that, a lot of times it's resting up against the unit. And I'll plug this in real quick so you guys can kind of get a visual of what I'm talking about. That wire would be touching right on that cabinet. So the second that I stuck this red lead to anything electrical in that cabinet, it would have shorted right there. And it could have been a bad scenario. So first thing you want to do is just look your stuff over, make sure it looks okay. Just run your hands over it, make sure you don't feel any cuts or nicks or anything like that. Also, you guys have probably heard me say it before, I always carry 2 of everything. At least 2 of everything. Because out in the field, 1 is none and 2 is 1. So if I were to only have 1 meter and something happened to this meter, my primary meter, I have nothing to fall back to. I'm stuck out in the field, I can't finish the job, I've got, a $250,000 piece of equipment and $1 million of product on the line, and a customer that's angry because I go, well, my meter just died, I don't know what to tell you. In a camper, that's probably not necessary, but, no more than a set of leads costs, it's probably worth it to carry 2 sets of leads. This is my Fluke 116. For a long time, this was my go-to meter. And we'll go over the functions that it has real quick. A lot of these meters, you're going to see the same functions over and over. They're all HVAC based meters, so they've all kind of got the same features to them. The first one we have an auto voltage, and what that does is that will determine whether or not the circuit is an AC or a DC circuit, and it'll automatically range my meter to that. And when I say range, so if I were to turn the meter on here, I'll show you. This will be the easiest one to see everything on. If I were to turn it on here, you can see down here I've got a little bar graph, and that's the range. So this meter has a range of up to 600 volts. I can change my range to see a different, to broaden my scale or make my scale smaller. That's all that means. It's kind of a nice feature doing the stuff that I do, because some of my temperature sensors and things like that have a very low range, so I'm able to dial this way down to see that when I'm checking them, or dial it way up for bigger things.
3 minutes left.
The next feature is it has DC volts, If you're going to be carrying it in your camper, you better have AC and DC, because your camper is going to have AC circuits and going to have DC circuits in it as well. So you're definitely going to want at least AC and DC. This one has millivolts. You're probably not going to use that. I'm going to be completely honest with you. I use this for like flame rectification. Boilers and furnaces actually they send power through a flame to prove that the flame has lit, so that it's a safety feature so that it knows that the gas did in fact light. If the gas didn't light and the flame's not there, it won't be any electrical path. So again, that's not really necessary. The next one down is going to be ohms or resistance. Again, we talked about that. This one is a very, very handy feature to have. Any of you guys that have worked on cars know about test lights and things like that. This is my test light. Okay, and not only can I use ohms or continuity as a test light feature, I can also check resistors. I can check circuits to see if there's a pathway to ground, because if we have a pathway to ground, of course that ground wire being there as a safety measure is going to kick our breaker off. So next feature down is continuity, and again that's the test light feature, just without giving you the resistance value of your circuit. This one down is actually a capacitor tester. You find those on different motors. In HVAC, we see them a lot on fan motors. Residential and smaller single-phase equipment, you'll have capacitors on compressors, blower motors, things like that. That would probably be a handy feature to have for checking the air conditioning in the camper itself. This one has a temperature because it's the HVAC-based model. I think actually all of these have temperature. That's kind of a give or take. You could have that or not have that. It's really not going to make too much difference. If you want to check the supply air coming out of your air conditioner, that would be a handy thing to have. If you don't really care, then don't search one out that has temperature. And then the last one is actually, I'm sorry, this one up here was millivolts. This one is milliamps. It's used for flame rectification. Again, you're not going to really need that. But if we go back up here to our AC voltage, and you're not sure how well you can see it or not, like I said, this was my go-to meter, so it's got some wear on it. But you have a little yellow HZ. That stands for Hertz. If I hit this yellow button here, that actually puts it into Hertz, and I can check to see if we have a 60 Hertz circuit or what we have. In my field, that's used a lot for variable frequency drives. We can actually change the frequency to change the frequency going to a motor to speed it up or slow it down. But all these have just about the same features, and I'm not going to go through every single one.
15 seconds.
And show you every single one, but that's enough on the meters for right now. Okay, guys, I just want to say one more thing on meter selection before we get away from that. The one thing that I do want to say, and this is important, buy a quality meter. I know a lot of us like to go to Harbor Freight and get stuff. Don't go to Harbor Freight and get a $15 meter or a $10 meter. Guys, don't let your life rely on a $10 meter. My life certainly isn't worth $10. I don't know about yours. You don't have to go out and get, these are expensive. I'm not even going to sit here and pretend like they're not. You don't have to go out and get this quality of meter, but you can get a good quality meter for probably $30 or $40 at Lowe's or Home Depot. I know Home Depot sells the Klein brand. They have some meters. Those are good quality meters. Lowe's carries Greenlee. I don't have much experience with Greenlee, but I know Greenlee electric tools are decent quality tools as well. The one thing that you want to look for, and this one has got it, is up here. This is the Flute 116 true RMS meter. You want to make sure that it is a true RMS meter. Now, somebody out there is going, well, what in the world does true RMS mean, and why do I even care about it? RMS stands for root mean square. Okay? Root mean square is a mathematical formula that this meter does when we apply power to it. So if we go back to our picture here with our hertz, this is an average. 120 volts AC is an average. So it can be higher or lower depending on where it is in the cycle. The meter is doing the math for us to make sure that it's giving us a proper reading and the correct reading. Now, what true RMS means, if you're in a place where you have a lot of motors switching on and off, such as a power plant, a factory, a mill, something like that, where they have heavy loads coming on and off all the time, a campground with everybody's air conditioners turning on and off, that affects the sine wave. That affects this wave here, this line. So every time something comes on or off, this line gets distorted, okay? And some of these low quality Harbor Freight brand tools, when they show you that power, it may say that there's 20 volts on a circuit, or 10 volts, or 0 volts on a circuit, and you think it's safe to work on. But because when it registered the value, because it wasn't a true RMS meter, it did the math wrong. And it figured out, oh, it's 10 volts. And you think, oh, okay, it's safe to put my hands on that. But you find out, oh, no, it's not. There's actually a lot of power on that because of a fault in the meter. The other reason why I say get a high quality meter, if you... These all have ranges. This one is good up to 600 volts, and actually this one here, which I have to use in a lot of the power plants and things like that, this one is good up to 1,000 volts. So if I were to put 1,000 volts of energy onto this meter, it would destroy this meter. It's not designed for that. The reason that I choose Flute, and I'm not trying to do a commercial for them, but just so that everybody understands, the reason that I choose Flute is because these meters are rough, tough, and rugged. They are bulletproof. I've seen this particular, not this one exactly, obviously, but I've seen this model meter go up to, 1,200 volts, and the meter is done. I mean, there's no question about it. Throw this one out. It's a paperweight, but it doesn't explode. Some of these low quality ones that you can go to Napa and get a thing for $10, I'm sure. But, if you put too much power onto that, what is going to happen to me? These have fuses in them. They're very, very, very safe, tough, strong meters. That's why I choose them. But for throwing in your camper to use a couple of times a year, a Klein, a Greenlee, something like that is going to be substantial quality for what you need. I mean, if you want to get it off Amazon or something like that, get it off Amazon. I don't care. But on to what these functions actually mean and how we use them. So first thing I'm going to show you is voltage. Now all I've done here, set that there, and I'll plug my meter leads in. All I've done here is I've just plugged an extension cord into the outlet. And to demonstrate my little hot stick here, if we take this and we turn it on, and it'll actually give us a heartbeat. That's called a heartbeat flash, and that lets us know that it's on. If we take this and we stick it into the hot side, it lights up and it makes a tone. If we stick it into the ground, we don't get anything because there's no power there. If we stick it into neutral, we don't get anything because there's no power there. Only when we stick it into hot. And the neat thing about these, and this is what I was saying with the power pedestals and panel boxes and things, is I can actually just run this along this wire. I don't actually have to ever come in contact. Where this meter's not going to show me any power. If you can see on the front there, it's showing 0. It's not going to show me any power because these leads actually have to contact the tabs inside of this cord.
Do that again. Showing something.
What? This is ghost voltage.
Okay.
Yeah, my camera woman here is telling me that my meter is showing something. Guys, that's just ghost voltage. It's a very sensitive meter. I mean, probably if I just hold it up in the air, it might even show something. I don't know if it is or it isn't. I can't see it.
No.
No. Actually, neat little trick. I'll show you something cool. If we go over to millivolts and we set it for DC, fix this one, and I hold these two leads like that, that is my heartbeat. That is the -9 volts that is making my heart beat right now. That's millivolts, not volts, but it's kind of a neat thing you can do with the millivolts function. But turn this back off. Now, this one, if we take this and we put our black lead into neutral, and we put our red lead into hot, we should show. Oops, I don't have a good connection. There we go. We should show 120 volts, which we do. Now, if I hit this yellow button here, that's going to show me my cycle, which should be 60 Hertz. That's the volts function. Now, that is on alternating current. A battery is direct current. So if I have it on AC volts and I put it on this battery, we're not going to show anything, or if we do, it's going to be a negligible value on this. I think it's showing all zeros, but I can't see it that well. So that is why when we're working in our camper, we need a DC function as well, because then when I hook up to this battery, it's going to show me 9 volts, or it better, because this is a brand new battery out of the box. So that's why I say the things you want to look for: AC voltage, DC voltage. If you plan on boondocking and running off of a generator, you're going to want Hertz, because you're going to want to be able to check before you plug your power cord in, am I getting 60 Hertz or do I need to make adjustments? So that's those functions there. Continuity, if we go down a couple of clicks to continuity, continuity is that test light function again. So if we put these leads together and we create a circuit, it tones to let us know you have a path. Now, one thing that you can do, this tells us when we do this, our leads are good. We should show 0 or very close to 0 on the meter, because we should have very, very, very little resistance through these wires. Now, one thing that you can do with this, if you suspect that your fuse in your meter has blown, you can pull one of your meter leads out, because these two terminals should be fused if it's a good quality meter. And if I stick this one in, that tells me my fuse inside my meter is good. So if I ever think, oh geez, I stuck this thing on too much power, or I touched my leads together and I blew the meter up and something's wrong, that's how you check that. Now, I've been to power plants that people that work on power plants do not understand how to diagnose their own meter. So if you can diagnose your own meter using only your meter and your leads, you are better off than the people that work on the power. Probably not all of them. That's a blanket statement. But you can also use it. This is a blown fuse here. This is one that I pulled out of something that had an issue. And you can see that when I put my two leads together, I show no path, I get no tone, nothing. This one here is a good fuse. We put these two together, we get a tone, we'll show a path on there. It probably does show some slight resistance. And that's an incredibly handy feature to have. Now, if you have that feature, you probably have ohms. I'm not sure where you would use ohms in a camper, but if you got it on the meter, you might as well know how to use it. You paid for it. This is a temperature sensor that I pulled out of a large commercial unit at work. These work off of resistance, and the controller converts the resistance value that comes back to it from the sensor to a temperature value. This one is bad. It shows, I think it shows like 10,000 or something like that, and it should show like 70. So if we put that together, it gives us a value of, oh wait a minute, we're on the wrong range. Come on. Gives us a value of 0.3. So that's just telling us that there's 0.3 ohms of resistance going through here. I was wrong. This one is actually shorted together. I had two that were bad. I know one showed too high and one showed too low, so I just picked the one that showed too low. And the last feature that we will probably use will be capacitance. And that is, these are capacitors. These go in your air conditioner, or really they're attached to a lot of different motors, but I see them primarily on air conditioning motors because that's what I do. And what these do is, if we go back to the sinusoidal wave and our hertz, we go back to this for a second. See how everything keeps coming back to like these three key terms? So our power is starting out at 0, going up to 120, crossing 0, going to minus 120, and stopping at 0. Every time we cross 0, when we have a motor running, that motor tries to stop for that 1/60th of a second. Okay? And what the capacitor's job is to keep that motor spinning. Because that motor, when it sees that 0 voltage, it wants to stop. The capacitor is the one receiving a charge and discharging that charge to tell that motor, no, keep going, keep going, keep going, keep going, keep going, so that it runs in a nice, smooth, continuous circle. So these meters have a capacitance check function. You do have capacitors in your air conditioner on your camper. It's a handy feature to have to know, is my air conditioner dead and I need to buy a new one, or do I need to go out and buy a capacitor off of Amazon for probably 20 bucks? So what you would do, on the top of this is a dual function capacitor. This actually works the compressor off of this terminal, and it works the condenser fan motor off of this terminal. And if we look on here, there's two different values. It's a little bit faded, but this is a 40 for my capacitor side and a 7.5 for my fan side. And this middle terminal here is actually just a common. That's just, common means just that. It's a common hookup. So we have a common power source come to here, and then we have one side go out to our compressor, and we have one side go out to our fan. So if we check between common and our compressor terminal, we should show 40 microfarads. If we go from our common to our fan, we'll show 7.5. Now, don't get this confused. None of these terminals inside here touch. They're simply down the, see, if we go from fan to Herm, we get nothing. All that's going on in here is we have a plate in here, a plate right here, and a plate right here. And again, this is very simple definitions. And because there's power here, our compressor, if we were to look at it on a wiring diagram, our compressor actually has, through the windings, will generate power here. And this power here from our compressor wants to gather right here because there's power here. So as soon as this power here on common goes away, this power here goes away too. And that's what keeps the motor running. That's what keeps it going in a circle. And the same thing happens on the fan side. The only difference between that makes it a 40 or a 7.5 is how close or far away these plates are. But you know, if we go through here, through these two, there's nothing. This is like a quick down and dirty check to do a capacitor. There is a much more accurate way, but I mean 90% of the time, you know, the quick down and dirty way is going to get you the answer you need to know. One other thing, I know we've been doing a lot of work on this meter here, but one other function that you should consider, and this is a handy one, is if you notice these two look different from each other. This is a clamp meter. It's got this nice clamp up here. Well, if we look on here too, we also have one additional function. If we go to that function, that's an amp reading. And that will tell us how much work the circuit is doing. Every single electronic component has an amp rating. Everything from your phone charger that you plug into the wall, to your air compressor or your refrigerator, every single thing that uses electricity has an amp rating, and this reads that. I would really like to be able to show you guys this, how to use this function, but I don't have a way to do it right now. I may try and shoot some video while I'm at work of using this function and just edit it in. We'll just have to see about where I go. A lot of places that I go to have government contracts and things like that, so taking video is a huge no-no. But I can explain it to you. So if we go to amps, we can open this up and we'll clamp it around the wire like that. And you only do one wire at a time when you're checking amps. If you check more than one wire at a time, it's going to tell you 0 every time, I promise you. Just take my word for it, or go out and try it. But the reason that you're going to want this amp measurement is because you can wrap it around a wire, and we're going to pretend that we have power moving through here. Let's say it's a condenser fan motor. It's going to be pulling about 1 amp. So we check that, and we go down here to our screen, and we see, oh, it's pulling 3 amps. If we look on the side of our motor will tell us how many amps that it's rated for. And if we look on there and it says, well, this motor's rated for 1 amp, and we're registering 3 on our meter, we know that there is a problem with our motor. Either a bad connection, not the correct power going to the motor, or it's quite possible that the motor itself has just started to fail. And that's why that is a very, very handy feature for diagnosing something. Because remember, guys, amps are the amount of work that the electricity is actually doing. So if our condenser fan motor on our air conditioner is doing 3 times the amount of work that it's supposed to be doing, we know that we have an issue with that. So that's just one last thing you want to consider. Most of the meters that you're going to find at Home Depot and Lowe's are going to be this clamp style meter like this. And like I said, this has kind of become the one that I carry in my tool bag with me, just because it has most of the functions that I use right on it. It's got an AC and a DC voltage on it. It's got my ohms and my continuity testing. It's got my milliamps. It's got temperature, if I need to take a temperature with something. This has got a very accurate thermocouple in it. It's got a capacitance, and it's got my amp draw. So this is kind of my go-to. I use this one for when I get into air. The resistance on this one doesn't go up very high, so I use this one for my higher resistance temperature sensors. Unlike mini split air conditioners and things like that, some of these big commercial units have very high value resistors in them. And then this is anything up over 600 volts. I have to switch over to this one. But again, I'm not trying to do a Flute commercial. I'm sure it sounds like it though. But that's it, guys. As always, with electricity and with life, stay safe. If you don't know, ask. If you're unsure, it's okay to hire a professional. It really is. By all means, I don't want anybody to go out there and get themselves hurt. So if you have any questions or suggestions on some more functions that you want to see on the meters, or something that you would like to explain more in depth, leave them in the comments. I'm going to do my best to answer all those questions that I can. And also, if you're on the Facebook page, don't be afraid to message me a question. Or if you're out there working on your camper and you're like, hey man, I got like 9 volts coming out of this and it's going to here, I don't know what's going on, I can probably help you guys diagnose it right, through a couple of quick messages, especially if you have a good meter and you've got all the functions that you need. So as always, stay safe, and we'll see you on the next one. Okay guys, so I thought I was finished a minute ago, but as we were wrapping up the video and I started putting everything away, my wife, who's also my camerawoman, asked me how I learned all this stuff. And it goes back to a lot of reading and a little bit of in the field, and I had some great teachers along the way. But one book that I read that I learned a lot of this stuff from was Ugly's Electrical Handbook. And actually, before we were getting set up to do this video, I tried to find my copy. It's a little book. I mean, it's not even probably the size of this meter. But there is a ton of information packed inside that book. And I was really, really upset that I could not find that book. because it is one that has moved with me from company to company, service truck to service truck, amongst the years. I highly recommend, if you are serious about this and you want to truly understand what is happening in your electrical circuit, in your house, in your car, anywhere. I mean, the electricity may be a different, it might be DC, or it might be AC, or it could be on a variable frequency drive, or it could be, 575 volts AC, or it could be 120 volts in your house. The principles are all the same. And this is a great book. Like I said, I was really upset that I could not find this book. I probably lent it to somebody and never got the thing back. And I know that some of my HVAC guys out there that are watching this video, and some of my electrician buddies that are out watching this video, are screaming at me right now that I lost this book. But I will put a link to it in the description of this video. I highly, highly, highly recommend going out and getting that if you are serious about learning about electricity. It has got every single formula, equation, anything you need to know is in that book. And for the second time, that's all, guys.